Ladies and gentlemen, thank you for joining me in today's presentation. We're looking at very interesting topic in mathematics. With us here is a topic that, in fact, there is no year that WAEC will not set question from this topic. This topic is what we call circle theory or geometry. Before we dive into the theories, we have up to 12 theories under this circle geometry. Student tends to run away from this topic because of the theories involved. I promise you, at the end of this video, you will enjoy or you will find circle geometry very easy. I believe the laws of indices are very easy. So this circle geometry to the laws or the theories rather are easy too. I always tell students that naturally, if somebody is driving, you don't need to tell that person when to match brake. It will naturally come. Okay, the same thing with this theory. YA can give you a question that required you to apply two or more theories to solve a problem. So I promise you, at the end of this topic, you will find circle geometry very easy. But before we state all the theories, or maybe let's say five, let me explain the basic properties of a circle. Let's say if we have a circle like this, if this is the center of this circle, if I draw a straight line passing through this center, is what we call the diameter. This will be the diameter of this circle. Half of the diameter will be the radius. If I draw any straight line or any line from this center to the circumference, it will be equal. So it means this will be the same. This will be the radius, 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 this will be the radius. Okay? Again, if I draw another line here, that line did not pass through the center of this circle, but it touches the circumference at 2 points, the center as this diameter. It means this will be a chord. So let me write AB here. Length AB is a chord. Let's say if the center is all here, let's say CD. CD here is the diameter, and this is arc here, arc AB. This chord AB divides this circle into two segments, the minor segment and the major segment. The minor segment now will be this portion here, while the major segment will be the remaining portion. Because if I may decide to shade this part here, so this shaded portion here is what we call the minor segment. The unshaded portion is what we call the major segment. This is another properties of a circle that you need to understand before we move into circle geometry. It's very important. Okay. Again, this portion here is what we call a sector, where we have two radius with an arc, something like this. This is a sector. Okay, this is a sector. This is the radius, this is the radius, and this is length of an arc here. Also, this is a sector. So we can still have a sector from this uh, circle as well. It's one of the basic properties of circle that you need to understand again. We have chord, and this chord, I can draw another chord like this. Let's say E. This is another chord. I can draw another chord like this. Maybe F. Can draw another chord like this. Okay, so these are the basic properties of circle that you need to know before we move into circle geometry. Okay, let's move into circle geometry with this knowledge now. In this presentation, I will state only 5 theorems with illustration. Okay, I will not prove it, but I'll just state five. As I said, what you need as far as circle geometry is concerned, know how to state the theory, when to apply the theory, and how to apply the theory is very important. Theorem 1, Theorem 1, um, Theorem 1 states that the angle sustained by an arc of a circle, the angle sustained by an arc at the center of a circle is twice angle at the circumference. What does that mean? Theorem 1, angle sustained by an arc of a circle at the center, twice of it will give you the angle at the circumference. Theorem 1, let's say I have a circle like this. If this is the center, the angle that this arc, let's say arc AB, will sustain at the center of this circle. Let's say here is A, okay, or let's say here is 2A. This is the same arc. If we move this to the circumference here, the angle that this the same arc AB will sustain at the circumference here will be half of this angle at the center here. So half of this will be A. So it means if the angle at the center here is 2A, the angle at the circumference here will be A, half of it. I can decide to draw a chord here. In other words, if we have a chord AB, if we move from this chord to the center of this circle and still move from this arc to the circumference of this circle, the angle that this chord will form at the center, half of it will give you the angle that this chord will form at the circumference. So it means you must come from that chord to the center and to the circumference before this theory can hold. So this is theorem 1. It means if, for instance, we have 100 degrees here and we are asked to find the angle at the circumference here, twice of this, that's 2 times 100 will give us the angle at the center here. That will be 200. In other words, if we have 200 degrees at the center here, to find the angle at the circumference here, half of 200 will give us the angle at the circumference here. So that is theorem 1. Very important and very easy. Trust me, you'll like it, you'll enjoy it. Theorem 2, theorem 2, angle in the same segment are equal. Angle in the same segment are equal. What does that mean? Let me use circle again to illustrate this. Let's say I have a circle like this. This is the center. Let's say I have a chord. Let's say AB, chord AB. From these 2 points on the circumference here, if I move on the circumference here, if I draw a triangle to a point on the circumference, I'll move from that chord again to another point on the circumference and come back to that the same chord. The angle that this first angle will form at the circumference, let's say here is A, will be the same with the angle that this other triangle will form at the circumference here. It means A is equals to B. And we have the reason is angle in the same segment are equal. One thing with circle geometry is you have to state the reason in the bracket. Anything you are doing like this, you have to state the reason as far as WAEC is concerned. So A is equals to B. Why? Because angle in the same segment are equal. In other words, we can say angle from the same chord in the same, or a triangle from the same chord in the same segment are equal. Okay, so this is theorem 2. Let's move to theorem 3. Theorem 3, angle in a semicircle are right angle. Angle in a semicircle are what? Are right angle. That's theorem 3. What does that mean? Angle in a semicircle are what? Are right angle. If we have a circle like this with the center here, if we draw a straight line to pass through that center, of course, this is the diameter from basic properties of a circle. Okay? From these 2 points on the circumference here, if we join these 2 points to one point at the circumference here, the angle that will form here is 90 degree. So angle in a semicircle are right angle or at right angle. So angle in a semicircle are what? Are right angle. Right angle means 90 degree. Okay? So we can illustrate this. Let's say we have something like this. If here is 60 for instance, and here is y, they may decide to say find angle y, or let's say here is a, b, c. And they may decide to say find angle a, b, c. Angle a, b, c means we're looking at the angle that is at b. So we know from this theorem now that the angle here is 90 degrees. So it's just a question of 90 degrees plus 60 degree, remove it from 180 will give us the value or the angle y here. That's 150, remove 150 from 180, that will be 30 degrees. So the angle ABC will be 30 degree using this theorem 3. Okay, let's move to theorem 4 quickly so that we can move to the fifth one. Theorem 4, opposite angle of cyclic quadrilateral are supplementary. What do you mean by cyclic quadrilateral? Cyclic quadrilateral, when you have a quadrilateral inside a circle and the four corners of that quadrilateral touches the circumference. Okay, let's say we have a circle like this. Let's say we have a point here like this, and then we draw that point to this order. We draw something like this. You realize that we have four corners here touching the circumference. So it means if here is A and here is B, here is C, here is D, this quadrilateral that is inside this circle is called cyclic quadrilateral because of these 4 points touching the circumference. If only 3 points touch the circumference, is no more a cyclic quadrilateral, but it's just a quadrilateral. 4 points or 4 corners must touch the circumference. Their supplementary means sum up to 180 degree. It means A plus B is equals to 180 degree. You state the reason. Opposite angle of cyclic quadrilateral are what? Are supplementary. So again, C plus D is equals to 180 degree. The same reason. So if peradventure I decide to remove this B, I'll put 60 here. And I ask you to find the value of this angle here. Very easy. 180 minus 60, that will be 120. It means angle A is 120 degree. So this is theorem 4. Let's look at the last theory for this presentation. As I said, we'll look at only 5 for today. In my next video, I will continue from 5, that's 6, 7 in that order. Please, before I continue, if you have not subscribed to TJ's Maths and Further Maths Adventure, please press the bell icon so that you'll be notified whenever I upload a new content. Thank you very much. Theorem 5, the exterior angle of a cyclic quadrilateral is equals to the opposite interior angle. Exterior angle of a cyclic quadrilateral is equals to the opposite what? Interior angle. What does that mean? Let's say we have a circle like this. Let me draw something like this. Like this. I have something like this. This is a cyclic quadrilateral. Okay? If here is x, the interior angle here opposite it will be equal. So it means if here is 60 degree and you are asked to find x, for instance, you have to use this theory. Recall that exterior angle of a cyclic quadrilateral is equals to the opposite interior angle. So the value of x will be 60 degrees. Very easy. That's the reason. Okay. Why this is a cyclic quadrilateral? See the four corners here touching the circumference at 4 points. So this is theorem 5. Exterior angle of cyclic quadrilateral is equals to the opposite interior angle. Thank you for watching. Please do share this to your learned colleagues, and I see you in my next video. I'll continue with the sixth theorem, 7th, 8th, 9th, 10, 11, 12 in that order. Before we now look at how we can use these theories to solve as many problems as we can from circle theory. Thank you for watching.